Section 14.6 is about problem solving with rational equations. And when we think of problem solving, what you should be thinking about is applications. So we will be doing some applications of rational expressions and rational equations. And the first thing that we want to do is understand that there is a four-step process for this. And to begin with, the application problem that we're going to do is not really the most interesting one in the world. I'm sure there's probably a lot of you that say, why would I ever need to know this? And I fully agree with you. You probably wouldn't. But this one is fairly clean, and it's a two-statement problem. So we're going to try to think through this just so that we can figure out the rules. So what we have here is the problem says the quotient of a number and 9 times its reciprocal is 1. Find the number. So reading the problem, the unknown appears to be the number. So we could let the number be n. And that's because we don't know its value. And if we let that number be n, then it says something about its reciprocal. So the reciprocal of that number n would be 1 over n. Because that's the definition of a reciprocal, is that you take the number, and if the number is n, we always know that n can be over a 1, and reciprocal means that we flip it upside down and turn it into 1 over n. So then our next step would be to try to translate this problem. So when we translate this problem, we're going to read through the problem again, and it says the quotient of, which means there's going to be a division operation. And of course, we've already determined that we're going to choose the number to be n, and we've already chosen its reciprocal to be 1 over n. So then rereading what the rest of the problem says is the quotient of a number and 9 times its reciprocal. That indicates that 9 is multiplying times the reciprocal. Is, and is in almost all problems means there's an equal sign there. And then the last is that number and its the number's quotient and that of its reciprocal times 9 is 1. So at this point, we've translated our words into an equation. So at this point, we're ready to proceed to step 3. Pardon me while I try to straighten up our page. So at this point, we're ready to solve. Since we have an equation, we should be able to solve it. So n divided by 9 times 1 over n equals 1. First, we'll simplify 9 times 1 over n into 9 over n. So we have n divided by 9 over n is equal to 1. And then the way that we divide with a rational number or a fraction is we flip over that fraction and we multiply. So that now is again equal to 1. So since the n itself is over a 1, and we flipped over 9 times 1 over n to turn it into n over 9, we can now multiply, and n times n is n squared, and 1 times 9 is 9, and that in turn then is equal to 1. So if we multiply both sides times 9, 9 times n squared over 9 is equal to 9 times 1. The 9's on the left side of the equation cancel, which leaves us with just n squared, and 9 times 1, of course, is 9. And by the principle of square root on both sides of the equation that we learned, then we know that we can square root this side of the equation and square root that side of the equation, which means that on the left-hand side, the square root of n squared is the square root of n times n, and the square root of 9 is the square root of 3 times 3, and a pair of 3's comes out from under the radical because it has an index of 2 and leaves us with just 1 3. And then, by the same token, a pair of n's under a square root radical means we can bring those out, and that's equal to a single value of n. And we have n is equal to positive 3. Now, the other thing that we need to take into account is that the square root of n, or excuse me, the square root of 9 could also have been negative 3 times negative 3. And bringing those out, because it's an index of 2, would mean that n could also be negative 3. So we have two solutions. So we're ready to go to the next phase, which is where we interpret and then state which means we check and then we state the answer. So in the interpretation stage, we're going to substitute the values we found from the equation back into the original problem. And notice that nothing in the problem states that we're restricted to positive values, so we can check both of those answers. So if we choose n to be 3, then we have 3 divided by the quantity 9 times 1 over 3, which is 3 divided by, since 9 times 1/3 is 9 over 3, and then 3 divided by 9/3 is equal to 3 times 3/9, which is 9 over 9, and that equals 1, and so it checks. Similarly, negative 3 divided by And let's just go ahead and multiply 9 times 1 over negative 3 and say that that's negative 9/3 would be 3 times negative 3/9, which would be negative 9. Excuse me, it would be positive 9 because we have negative 3 times negative 3 is positive 9 over 9, which again equals 1, and so that answer also checks. So at this point, what we have left to do is to state the conclusion to our problem, and the conclusion to our problem is the missing number is 3 or negative 3. So there are our 4 steps for problem solving. Now we'll take on a somewhat more useful problem. Someone might actually need to know how to do this. If you have a construction company and you're trying to work on a job site, they're probably going to need, you're going to need to know how many hours to allot for them to do that, so that when you charge your job, you'll know how much time to charge for. So an experienced roofer can roof a house in 26 hours. A beginner needs 39 hours to do the same job. How long will it take if the 2 roofers work together? Now we need to reread the problem and make sure we understand what's going on. We know that the experienced roofer can do the whole house in 26 hours. We also know that the beginning roofer needs 39 hours to do the same job, so he can do the whole job in 39 hours. And then we have the question, how long will it take if they work together? Now, one of the things you want to take into account before we ever start this problem is that it doesn't make sense that if the roofers work together, that the entire job is going to take 26 hours or more. Because the experienced roofer can do the whole job if the beginner sits there and doesn't do anything but clean his fingernails or drink tea, and the experienced roofer does the whole job. So assuming the beginner does much of anything, then the roofing job is going to get done in less than 26 hours. Now, we know that the beginner has been able to do a job, the same job, in 39 hours. So this means that the beginner is ready to work partnership with the experienced roofer. So together, they're going to do this job. By using these times that we've got for each roofer to complete the job alone, we can find their corresponding work rates. And this is what we call a work rate problem. So their work rate is the portion of the job that they can do in 1 hour. If they work together, then their total time is T, which is what we don't know. That's our unknown. But every hour working together, they can do 1 over T of the job. In other words, if they work together and they could do the job together in 10 hours, let's say, then each hour they would have done 1/10 of the job. So now returning to what we know about the experienced roofer, the experienced roofer can do the whole job in 26 hours, which means his job rate is he does 1/26 of the job in 1 hour. And in the same way, The beginning roofer takes a total of 39 hours working alone, which means when he works alone, he can do 1 over 39 or 1/39th of the job in every hour. So we can use that fact to help us solve this. Send your workers out. So at this point, we're going to translate what we know into an equation. Since we know the rate of the workers working together would be equal to the sum of their individual rates, then let's put their individual rates down. The experienced roofer can do the entire job in 1 over 26, or he does 1/26 of the job per hour. Whereas the inexperienced roofer can do 1/39th of the job per hour working alone. But here they're working together. So you add their two rates, and when we add their two rates together, that should give us 1 over t, which is the total time that the job needs to be completed in. So they can do 1 over t of the job per hour working together. And now we have an equation that we can solve. So we're going to solve this equation. 1 over 26 plus 1 over 39 is equal to 1 over t. And for this, we need a common denominator. We're going to need our LCD that we're going to multiply everything by. So our least common denominator, kind of obviously, is going to have a t in it. And then we have 26 and 39, so we need to figure out what the least common denominator is. And the way we do that is we take 26 and we break it down into its prime factors. It's even, so we have 26 times 13, and 13 is prime. So those are the two prime factors of 26. Then we have 39. 39 obviously is not even, so we'll try dividing it by 3, and we find that 3 goes into 39 13 times, so there again we have 3 times 13, and that means that our least common denominator needs to have just 1/13, plus it needs to have a 3, and it needs to have a 2. And that product is 78. So we could say that the LCD is 78T. But as you already know, I prefer to leave things factored out. So rather than do that, I'm going to leave the factors of the LCD and use that to multiply through by. So our LCD is 2 times 3 times 13 times t, and we're going to multiply that by our first fraction, which is 1 over 26, and 26 is 2 times 13. Plus our same LCD again, 2 times 3 times 13 times t times 1 over 13 is 3 times 13. And then we're going to take the LCD one more time. And we're going to multiply it by 1 over t. So that when we do that, we see that this 2 cancels that 2, this 13 cancels that 13, and what we have left then is 3 times t, or 3t, times 1. And then we'll move to the next term, and this 3 cancels that 3, and this 13 cancels that 13, and what we have left is 2t times 1. And then at the end, on the other side of the equals, we only get rid of the t, so what we have left is 2 times 3 times 13, which is, as we already know, 78. We've only gotten rid of the t. So this leads us to the equation 2t plus 3t, which is 5t, equals 78. And if we divide 78 by 5 and 5t by 5, then we have that t is equal to 78 over 5 hours. And that is about 15.6 hours. So then move to the next step, which is to interpret our problem. First, we need to substitute our value back in to check it. So to do that, we have 1 over 26 plus 1 over 39, and the question is, does that equal 1 over 78? And in fact, it does. If you enter that into your calculator, parentheses 1 divided by 26, close parentheses plus, parentheses 1 divided by 39, and then choose to have the answer as a fraction, that is the answer that you get. I'm sorry, I forgot to write down 78 over 5. Sorry about that. And actually that comes out to be 5 over 78. So the statement that answers the question is, the roofers would take 15.6 hours working together to finish the job. So we have stated our answer in a sentence that answers the question posed in the problem. Now we're going to start solving problems about distance. And distance problems really aren't much different from work rate problems because we're talking about a rate. And in the distance formula, in words, sorry about that, distance is equal to rate times the time that it took to travel that distance at that rate. So we're going to solve an example of that kind of problem. So here's our problem. The speed of the lazy river's current is 5 miles per hour. A boat travels 20 miles downstream, in other words, with the current, at the same time as traveling 10 miles upstream, which means they're going against the current. And we need to find the speed of the boat in still water. And since they're talking about a distance and a traveling rate, and we know something about the time, then we're talking about a distance problem. You should be aware that the distance problem, d equals RT, can be solved for any of the variables. In other words, t would be equal to d over r. Or, for that matter, r would be equal to d divided by t. And it's going to be the fact that t is equal to d over r that we're going to use. So we're going to use the middle version of that formula. So the first thing we look at thinking about this problem, it says that the rate of the boat downstream, that would be the rate of the boat in still water plus the rate of the water current. And by the same token, the rate of the boat in going upstream would be the rate of the boat in still water minus the water current. And the thing that we know is that going downstream, the distance was 20 miles. And going upstream, the distance was 10 miles. What we're trying to figure out is the speed of the boat in still water. So we're looking for rate. So knowing what we know, it goes 20 miles when the rate is the rate of the boat in still water plus 5 miles an hour for the current. And when it goes upstream, going against the current, its rate in still water is being pushed back by the current of the river, so it's the still water rate minus 5 miles per hour. The time is distance over rate. So the time downstream is going to be 20, which is the distance, over the rate, which is r, plus 5. And then upstream, the time was 10 miles for the distance, and the rate of the boat was r minus 5. And we know that the speed is the same in both cases. So now we'll translate that into a problem and an equation that we can solve. And since the problem states that the time to travel downstream, say stream, was the same as the time to travel upstream, that means we have those two set to be equal to each other because the two times are the same. So again, we're going to need to find an LCD, and our LCD is R, well, let's not use a capital R. You'll get in trouble in my math lab if we do that. R plus 5 times R minus 5. So there's our LCD. And we're going to need it on both sides. And we're going to multiply the left-hand side by the LCD and the right-hand side by the LCD. And on the left-hand side, the R plus 5's cancel. And on the right-hand side, the R minus 5's cancel. So here's what we have left. 20 times R minus 5 is equal to 10 times R plus 5. So that means that 20 times R is 20R, and 20 times negative 5 is negative 100. And 10 times R is 10R, and 10 times 5 is 50, positive 50, because it's positive 5. And then what we'll do is we'll subtract 10R from both sides, which gets rid of it over here. And then we'll add 100 to both sides, which gets rid of that over here. And the equation that we have left will be 20R minus 10R, which is 10R, is equal to 50 plus 100 is 150. And if 10R equals 150, and we divide both sides by 10, then 150 over 10 tells us that R is equal to 15. So we think R is equal to 15. We need to go to step 4. I'm sorry, we've already done step 3. I'm going to go to step 4, which means we're going to check, going back to the original problem, 20 over 15 plus 5, and is that equal to 10 over 15 minus 5? And in fact, 20 over 20 is equal to 10 over 10, because they're both equal to 1, so that's true. So then the speed of the boat in still water is 15 miles per hour. And that is the conclusion of our lesson for section 14.6. And you should be ready to do your 14.6 homework.